This is the second half of the lesson for Handout 3A. So taking a look at our first problem, it talks about a parallelogram. So the width of a parallelogram is 2x plus 5, and its length is x minus 7. Find the area. So if you're a little unsure, again, draw a picture of what's going on. So here we have a length, or a width, of 2x plus 5. The length is x minus 7. So when we're trying to find area, area is just length times width. So let's go ahead and substitute these values in there. So 2x plus 5, and that's being multiplied by an x minus 7. So here we get to use that FOIL method, the first, outer, inner, last. So remember, the first terms are the 2x and the x. Those multiply together, and we end up with a 2x squared. Then we move on to our outside terms, and those get added together. So the outside are 2x multiplied by the negative 7. So plus 2x times by the negative 7. That gives us a negative 14x. And then we move on to the inside terms. So we're now multiplying 5 by x. Those are my inside terms. And when I do that, I end up with 5 times x makes a 5x. And we have our last terms. So 5 gets multiplied by negative 7. So 5 times by negative 7 makes a negative 35. So now we're able to combine some terms. So we got the negative 14x, the positive 5x. Those combine together as 1. So we still rewrite the 2x squared. And then when we subtract those two numbers, we get a negative 9x, and then minus the 35. And that is the area of that parallelogram. Well, looking at the next one, it says find the roots of the equation. Well, they could also say find the solutions, the x-intercepts, the values of x when y is 0, or find the zeros themselves. And so whenever I solve one of these, basically I'm trying to find out what, again, the x-intercepts are. I'm going to try to factor first, because factoring is always the fastest method. And so when I do this, I see 5 times by a number needs to make 5x squared. So it's got to be 5x and x. So if I have a prime number, I start with that. Now, when this is a negative, that tells me that the outside terms and the inside terms are subtracting, because they're opposite in sign. The last terms are opposite in sign. They subtract to make negative 8x. So when I do this, I want to get a number, 5 times a number, that gives me something a little bigger than 8. So I'm going to try multiplying it by 2. And then I'll put the 2 here. And so you see this makes a 10, and this makes 2. And I can get those to subtract to make negative 8 if I make the 10 negative and the 2 positive. So positive 2, negative 10. And so from that point, we can take those two factors and find the roots. So we can go 5x plus 2 equals 0, and I can do x minus 2 equals, oops, not x equals, but x minus. So let's fix that. X minus 2 equals 0. And so when I solve this one, I need to subtract that 2 from both sides. So that's how I'm getting the negative number, but then I need to divide by 5. So that's how I'm getting negative 2/5 as one of the answers. Over here I have to add the 2, and I end up with x equals 2. So those are my two answers. My answers would be that negative 2/5 and the positive 2. So there they are. So taking a look at our next problem, we have a 3x squared, and it's minus a 2x equals negative 7. What they're asking is find the number of times the graph crosses the x-axis. So all they want to know is just how many times. They don't want to know what those values are. So what we're going to end up doing is using what we call the discriminant. And the discriminant is this. It's a portion of this quadratic formula. Remember, the formula goes negative b plus or minus that square root of b squared minus 4ac all over 2a. That's the formula. Now, what makes us figure out how many solutions there are this part right here. See, this b squared minus 4ac, if this number here is a negative, so if b squared minus 4ac equals a negative number, that means that we would have no solutions, because we can't take the square root of a negative. We don't have any x-intercepts. So this means no solutions, no x-intercepts. And so if the b squared minus 4ac was equal to a 0, that means we would have just one solution. We'd have negative b over 2a, because it would cancel out the square root symbol. So we'd have one solution. And if the b squared minus 4ac was equal to a positive number, then we would end up with two solutions. Two solutions because you see the plus or minus sign, we'd have to add that value to negative b, then divide by 2a, and then subtract it from negative b over 2a. So what we need to do first is we need to figure out what the a, b, and c terms are. So in order to do that, I need to set it equal to 0. So that's the first step. So now I've got 3x squared minus 2x plus 7 equals 0. So what I've got here is an a term right here, a b term, and my c term. And I'm just going to substitute those into that discriminant. So I've got b squared, so negative 2 squared, minus 4 times by a, which is 3, times by 7, or c, which is 7. And I do that work, I get 4. Now this negative 4 times 3 makes negative 12, times 7 makes a negative 84. So when I do that subtraction, I end up with a negative number. So negative 80 tells me I have no solutions, no x-intercepts. And the reason is because of that negative sign right there. You can't take the square root of the negative. Well, let's go ahead and do this proof for this quadratic formula. Where does this come from? Well, it comes from this first equation, ax squared plus bx plus c. And we set it equal to 0. See, this is where those variables a, b, and c come from. Now, how do they get it from this form to this form? Well, here's what we do. What we're going to end up doing is completing the square. So the first step I'm going to do is I'm going to subtract the c from both sides. So when I do that, rewrite my equation, and I now have ax squared plus bx equals negative c. And so from that point, now I need to get rid of this a, because I need to make this a perfect square. And so the way I'm going to do that is I'm going to divide this entire equation, each of the numbers, by a. So both sides. So when I do that, I'm going to rewrite my equation, and now I've got x squared plus b over ax equals negative c over a. Alright, so from this point we complete the square, just as we had done before. Remember, we take half the b term. So we're going to take this b over a, and we're going to multiply it by a half. And that's going to give me b over 2a. And remember, this is what the factored form is. This is the number, b over 2a. That's the value that adds together by itself to make b over a. And so I need to take that b over a, and I need to square it, because the last term in each of the binomials is going to be b over 2a. And b over 2a times b over 2a is going to give me the c term, the last term. And so that's going to be the b squared over 4a squared. Now how did I get that? B is being squared, 2 is being squared, that's how I got the 4, and the a was being squared. So that's what I have to add to both sides. So I'm going to add that here, b squared over 4a squared, and I need to add it over here, b squared over 4a squared. And so now I'll rewrite my equation, and I'm going to go ahead and write it like this, x squared plus b over ax plus this b squared over 4a squared, and this all equals this negative c over a plus b squared over 4a squared. So what I need to do from this point is I'll need to rewrite this trinomial in the factored form, and so I'll be able to do that. But before I do that, let's go ahead and do some work to this. I need to come up with a common denominator to add these fractions. Well, you see this has an a, this one has two a's and a 4, so that means I need to multiply this by 4a. So you can start to see where this 4ac comes in right here, 4a times negative c. So let's go ahead and rewrite what we've got now. So I'll factor this trinomial, and it factors to x plus b over 2a, quantity squared, because b over 2a plus b over 2a make the b over a, and they multiply to make the b squared over 4a squared. This all equals, now when I combine this, this is a 4a times negative c. So I'm going to write this as b squared to start with. So I rewrote this minus 4ac. See, 4a times negative c just makes a negative 4ac, and I just wrote it in descending order, so the variable that comes first in the alphabet to the one that comes last, over 4a squared. So from this point, what I need to do now is take the square root. So take the square root of both sides, square root of this side. Now notice how the square root symbol went down for the fraction as well, so not just the top, but the bottom. So I go ahead and take the square root, and that'll just cancel out the squared symbol, x plus b over 2a equals, now on this side I've got the square root, so plus or minus. Now I couldn't take the square root of the top because of this 4ac, so I've got b squared minus 4ac inside the radical sign, and then down below I can take the square root of this. So the square root of 4 is 2, the square root of a squared is a. I can take the square root because they're factors, they're being multiplied. So from this point I just have one step to go. All I have to do is subtract the b over 2a from both sides. So I do that over here, minus the b over 2a. Now notice the denominators are the same. And that'll always be the case when we're completing the square. At this stage, the denominators will be the same. So all I'm going to do is just rewrite the negative b first. So negative b plus or minus the square root of this b squared minus 4ac. And this is all over 2a. And so that's where that quadratic formula comes from. It comes from completing the square of the original equation that we had as ax squared plus bx plus c, and set that equal to 0. So those are some of the problems that you'll see on tonight's homework. Good luck.